Hey there everybody, Mr. Marek with you. In this video lesson, I'm going to attempt to demonstrate for you Newton's second law, which is the relationship between acceleration, force, and mass. As it turns out, the acceleration of an object depends on two things: how hard you push it, that would be like the force, and how big it is, how much mass it has. So the first experiment we're going to do is change the mass of something and see how that affects the acceleration. So I've got this smart card here, and the smart card is connected to my laptop, which is right over here. And on the laptop, I've got Capstone pulled up, and Capstone is currently giving me a graph of velocity versus time. And of course, from that graph, I can then get the acceleration by finding the slope. And I was trying to do a screencast where I could show you both of these things at once, but it kept crashing my computer. So I'm going to do just a video showing you the experiment, and then I'll go through the data a little bit more carefully in a screencast, because trying to do both at one time kept crashing my laptop. What we're going to do is push this cart with this fan, and the fan is connected to the laptop as well, so that when I press record, the fan turns itself on automatically, and then it'll turn itself off after it's gone about 3/4 of the way down the track. And that way I get a nice constant force. Then I can change the masses by adding these little mass bars to this thing right here. And so what I'm going to do is I'm going to do one really light one and then one really heavy one where I put all these things on there just so that we can see it. And then I'll show you guys the data on the screen in a separate screencast. So let's try this out. I'm going to click on the record button on my laptop, and that should turn the fan on in about a second, and we'll see the fan accelerate. Alrighty, and it hits the end of the track and then it rolls back real nice so that I don't have to go over there and fetch it or anything. Okay, so on the screen, on the computer screen, I now have that nice graph of velocity versus time. And what you'll notice, make this a little bit bigger here, this little curvy part right here at the beginning, that's the fan turning itself on. And so it's not pushing at 1 second, and then at 2 seconds it starts to push a little bit, and then the push gets bigger and bigger and bigger. So we're not going to do anything with that part. Here at the end, you'll notice that it kind of has an opposite shaped curve. As the fan is turning itself off, that velocity starts to level out. So what we're going to do is we're going to choose just the part in the middle where the force exerted by the fan is constant, and therefore the acceleration is constant. So clicking on my linear fit button, I get an acceleration of 0.162 meters per second squared. And so I'm going to keep track of that over here along with the mass on a piece of paper so that I can then plot that and see how the added mass is changing the acceleration. Okay, so let's put this back here like that. And let me go ahead and load this bad boy up with a bunch of additional mass. And so I'm going to put 2 of those mass bars in there. 2 is not enough. Let's go for 4. Let's really go nuts with this. There it goes. Okay, so now I've gone from about 1/2 kilogram to 1.5 kilograms. So I've tripled essentially the mass of my cart. I'm going to click on the record button again to start a new run. Clear this out first. All right, here we go. 3, 2, 1, record. Fan turns on. All right, so what you'll notice immediately is that it took a lot longer for that cart to reach the end of the track, even though the fan was pushing with the same amount of speed, the same amount of force. And so it took a lot longer to get all the way down there. If we look at the data, and you'll have to trust me that I didn't change the scaling or anything like that, you should notice that the line isn't as steep as it was before. And if we do the same thing where we choose just the linear part. So let's kind of narrow it down a little bit to about right there, And let's do our best fit line. So you'll notice here that now I've got a slope of 0.052. So basically like a quarter of what it was before. So by adding more mass, I changed the acceleration of my cart, and by making the mass bigger, I made the acceleration smaller. So what I'm going to do is collect the rest of the data by using the different sizes of the mass bars, and then I'll create a screencast where I can show you what the data looks like and then graph it along with you. So I'll see you in just a few seconds. Ta-ta.